Greetings! Back to the videos in chapter 11. So this is section 11.3. We've already talked about some of the things on this paper. So yes, you need a template, hopefully, that you got in class, as well as a graphing calc might come in handy. So I'm just going to quick kind of review some of the stuff we've already discussed. There's a picture here, as well as some of the words that we put on a different sheet in class. So just to say it out loud, sine and cosine are known as periodic functions. And their domain is all real numbers. We'll talk about range here in a second. So we got a picture of sine and a picture of cosine. Just one cycle of each, just to be able to look at to talk about these different words, just to do a quick review. Okay, so amplitude is basically just the distance from the middle line. So you can see here the amplitude, and it's shown also over here for the cosine. And it's usually shown as absolute value because it is possible that we could have something like y equals -2 sine x, which will be a reflection in the x-axis, but the amplitude is still going to have the value of 2, the length of 2. Okay, frequency is the thing in the B position if you're looking for it in your equation, and that tells you the number of cycles of the curve in 2 pi. So sometimes you get frequency and this thing called period mixed up. So frequency is basically like how frequently does it do its thing in 2 pi, one lap around the unit circle. Now if we take 2 pi and divide it by the thing in the B position, that gives us the period. That tells you how long one cycle takes. So just in the boring old y equals sine x curve, if you just want to have kind of a place to go back to, remember it takes 2 pi to go once around the unit circle, so this is a 1. So when you take 2 pi and you divide it by a 1, you get 2 pi, which is the length of one cycle of just y equals sine x. So maybe going back to something like that will help you. So frequency and period. Horizontal phase shift. Oh, also, I don't know, maybe this sheet would help you here. Just noticing like this is labeled. That's a period, one cycle, one class. We have a period. Okay, horizontal phase shift then is when we do something to the graph that moves it left or right, and it does the opposite of what we would expect. If it's a plus within the parentheses, it goes left. If it's a minus, it goes right. The vertical shift behaves a little better because if it's a plus, it goes up, and if it's a minus, it goes down. So then the range for these different variations of this function, now if it's just boring old y equals sine x, the range is going to be -1 to 1. But if we start doing things and making it a fancier equation, the range is going to be affected by how this thing is moving. So if it moves some distance d away from the normal x-axis, then the max is going to just be whatever that value is. Say it's +2. You're going to take that +2 and add whatever this amplitude is. That gets you to your max value. That max value. And then likewise, if you want to find your min, you just take whatever that movement is, wherever it's been shifted, and subtract the amplitude. And so those maxes and mins then are going to tell you what the range of the function is once we start getting into fancier functions. So it's going to go from the minimum to the maximum. Okay, so those are like the things you need to know about these functions. So I just have some examples here. If you feel like it, you can stop the video and try it and then, check in how I did it. I like to start with this one because it's not traditional. It's, a problem, a real world problem, and so it sort of forces us to make sure we understand what the heck we're supposed to do here. Okay, pet store clerk noticed population in the hamster habitat varied sinusoidally with respect to time in days. So you have a lovely graph here. Carefully collected data and graphed his results. From the graph, determine amplitude, period, frequency, and the vertical shift and phase shift. So let's start with amplitude. So you can see we don't have an equation to look at, so it's just sort of a good thing to try to start wrapping our head around. Well, what the heck is amplitude? So amplitude then is going to be the distance up and down from the midline. So then how is it we're going to figure out what the midline is? Well, if I just sort of draw across here, I can see where the top of this thing is. And if I draw across here, I can see where the bottom of this thing is. So hopefully it would make some sense to you then that the amplitude is just going to be halfway between 18 and 2. So to figure out the amplitude, then I really just need to know, well, what is the distance between 18 and 2, and then divide it in half. So 18 minus 2 is 16, and 16 minus 2 then is 8. Okay, that's amplitude. Okay, what is the period? So the period is how long does it take it to do its thing once. And so this is another one where you kind of have to take a look at your graph and sort of find a starting point and a finish point. And sometimes it's hard, based on the graph, but it appears that if I want to find basically just one cycle, this is a low point here. And so then I'm going to come back up and I'm going to come back down and find another low point, which I would say is probably meant to be about right here. So that would be one complete cycle. And as long as I'm starting and ending at a place that just gives me one cycle, I should get the right number. So the period then is from 27, from 2 or 3 to 27. So if I subtract that, the period is 24. Okay, so now it's asking us for the frequency. So from up above here, we have an equation that tells us that we take 2 pi divided by b, which is the frequency, and that's the period. So let me write that down. So 2 pi divided by b is going to be equal to the period. So in this case, I'm trying to find the frequency. So I'm just going to make this into a little proportion. I'm going to take 2 pi divided by b and set that equal to the period, which I know to be 24. So when I cross multiply, I get 24b equals 2 pi, and divide both sides by 24, I figure out what my frequency is. 2 goes into 2 ones, 2 goes into 24 12 times, so it's pi over 12. So that might feel a little odd. Just to imagine the frequency being pi over 12, it's kind of hard to wrap your head around that, but this is basically just using these relationships. Okay, the vertical shift then is how much has this thing moved up or down. So to figure out what the vertical shift is, hopefully it would make some sense to you that the midline really is what we need to find. So the midline would have to be located basically halfway in between the high point and the low point. So the vertical shift then, if you think about halfway in between, it's really just the average. So take 18 and add 2 and divide that by 2. So 20 divided by 2 is 10. So the vertical shift is 10. And if you were to actually draw a line across here, hopefully you can tell that looks like kind of where the middle of this thing is. Okay, and then last is the phase shift, and that is how much is it shifted from the y-axis. So the phase shift, so if we look at the phase shift in this case, instead of starting here at 0, it's starting over here at 3. So it has shifted 3 to the right. So the phase shift would really technically be a negative 3 because it's moving right, therefore minus will be a negative 3. So that's sort of a different real world problem, kind of forcing these new terms on you. So some of these next ones I think you're going to say, well, those are easy. Okay, so what is the amplitude of the function y equals 2/3 sine 4x? You just say the amplitude is the thing in the A position, therefore it is 2/3. And these next problems, if you want to just stop the video and flip your sheet over and see if you can do them on your own and then turn the video on to check them, you can feel free to do that. Okay, path traveled by a roller coaster modeled by the equation y equals 27 sine 13x plus 30. What is the maximum altitude of the roller coaster? So this is a problem where this whole thing has been shifted up 30. So it's already up 30, but then to that 30, to get to the maximum place, we need to add the amplitude, which is the thing sitting right here. So 30 plus 27 is 57. Doesn't say how, if it's feet or whatever, so it would be 57. Okay, what is the frequency of a wave represented by the equation y equals 2 cos 6x? So if you remember, the thing that is in the B position is the frequency. So the frequency is 6. as in how many times does it do its thing in 2 pi. That's what frequency is. Different from the following question. Certain radio wave travels in a path represented by the equation y equals 5 sine 2x. What is the period? So this time we want to know how long does it take to do its thing once. So to figure this out, I'm going to take 2 pi and divide it by b. And so in this case, the period is pi. It'll do its thing in pi radians. Okay, now you're going to get more practice down the road sketching these, but this section starts you off just trying to, learn how to sketch a cycle. Now you could use your calculator, but for right now I'm going to go ahead and see if I can talk you through this without a calc. So, things that we care about in order to sketch one round. I want to kind of get my facts together and then I'll start trying to make a graph. When I look at this, I'm going to just first start and say, is there any kind of a phase shift? Is this thing moving at all? And I can see that there is nothing in parentheses, so there is none. So that's going to make my life easier. I do need to know what the period is. If I want to get one cycle, I need to know how long one cycle lasts. So the period is equal to 2 pi over the thing in the B position. So this thing does its thing in pi. I also want to know what the amplitude is, and in this case the amplitude is 1. So in order to sketch this, I'm going to go ahead, I'm going to set up my little grid, and I know basically every one of these has 4 sections that if I divide it like that I can kind of more cleanly draw it. So in this case it's going to get this whole thing done in pi. So the halfway point is pi over 2, and half of a half is a fourth, which is pi over 4. And if you struggle with the fractions, one way to think about this is I could count by pi over 4. So pi over 4, 2 pi over 4, so this would be 3 pi over 4, or 3/4 pi, which then gets me to 4 pi over 4, which is pi. My amplitude is 1, so it's going to go up to 1 and down to -1. And so now basically I can just plot some points and get this thing going. It's a sine curve, so I know I'm going to have a point here, a point here, point here, point here, and a point here. And once I get those points on and I have my grid set up, it's usually pretty easy to get that baby on the paper. Okay, just for practice, I'm going to give you kind of a harder one. Some of the ones that are in this problem set are not as difficult as this, but just to kind of think about it a little bit. So, y equals 2 cos x plus pi over 4. So let's start in the same way. So notice, yes, we have a phase shift. Okay, so since, actually I don't want to draw that arrow, it'll be confusing here. So the phase shift then, since this is a plus sign, the phase shift is going to the left pi over 4. Okay, the period for this guy is going to be, since there's no number in front here, it's just going to be 2 pi over 1, or 2 pi, which we're sort of used to. And the amplitude then, there's a 2 sitting there, so we're going to have an amplitude of 2. There's no vertical movement at all. Okay, so half the battle for this one is setting your grid up. So I'm going to go ahead, and unfortunately if you struggle with fractions, this one might hurt you a little bit. So I know I have to start the operation over here at negative pi over 4, at a quarter, negative a quarter. Now, knowing that this is going to take 2 pi to do its thing, basically I need half a pi, half 4 times. So since this is a quarter of a pi, I'm going to need 2 quarters to get to a half a pi. And then I'm going to need 2 more quarters to get to my midpoint, 2 more quarters to get to my third position, and then 2 more quarters to get over to the end of this thing. So if I'm at negative pi over 4 here, I'm going to be at pi over 4 over here. Now, I'm going to just go ahead and count by pi over 4. So pi over 4, 2 pi over 4 would be pi over 2. 3 pi over 4, 4 pi over 4 would be pi. 5 pi over 4, 6 pi over 4 would be 3 pi over 2, and 7 pi over 4. Now, in reality, you don't necessarily need to label everything on this thing, but you do need to pin down enough points so that you can accurately show what's going on here. Okay, now since this guy has an amplitude of 2, and I'm controlling this graph, I'm just going to go ahead and label this 2 and this -2. And then I got a little more to think about, and that is that this thing is cosine. And cosine has a different shape. Remember, cosine basically does one of these, while sine does one of those. So I'm going to start over here at -pi/4 and put a point. And then I'm going to come over here and put my next point, which is going to be at pi/4. And I'm going to drop down to the low point over here, and I'm going to come back up, and then I'm going to finish the job off over here. So as best I can, I am going to go ahead and graph that in. So that one's a trickier one because the grid setup is definitely a little bit more painful, and we'll be doing more practice with it. I just wanted to give you sort of a first shot at it. And you could try putting this in your calc also and just see what it looks like and see if you reset your window how it would look. So that's it for this. Go to Math Excel for School, and there's a Section 11.3 online homework to practice with.